Hi class, this is just a quick video to go over when you need the chain rule and when you don't. I know we learned so many different methods of finding derivatives and it can get really lost in your head, so I just wanted to make this quick note so that you had a reference to go to. So in general, you need the chain rule when your argument is anything other than just one variable. So when you have a long thing being raised to a power or the square root of something other than just x, for example, is a good rule of thumb. Or when you have a situation where you have two functions and you need to compose one into the other. So for polynomials, something like this one on the left, you don't need the chain rule. Everything that's being raised to a power is just one variable, it's just x. So in this case, the chain rule is not needed. However, in the second case, the chain rule is needed because you'll notice the argument that's being raised to the power 3 is something other than just a variable. X squared plus 5 is all being raised to the power 3. So in this case, you would need the chain rule. So just for this one, I actually will quickly find the derivatives just to talk about it. So in this first case, the derivative is just 3x squared plus 4x plus 0. So you just keep it at that. Now the biggest difference over here is that you bring down the 3 and you reduce that to 2, but then you have to multiply this by the 2x, the derivative of what's inside here. Okay, and then this would be 4x plus 1 to the power 1 times 1. So now I guess technically you could think about these as multiplying them by the derivative of just x, but that would just be 1 every time. Okay, now this next one with radicals, so square roots. You don't need the chain rule if you're taking the square root of just an x, but you do need the chain rule when what's under your square root is longer than just one variable. For products of functions, okay, so this is a product of functions because it's one function times the other. But notice that both functions are just polynomials. Okay, but in this product rule question, one of the products itself is a composite function. So there's this function that's all being raised to the power 5. So when you get to the function, then you will actually have to take, when you get to taking the derivative of this first half, you will have to use the chain rule. While I'm thinking here, another example would be if you had something like f at x equals x squared plus 3x times 2x cubed plus 7, all to the power 5, like that. So the difference between this one and this one is this first one I would think of as primarily a product rule question. So you have a function times another function. It's just that one of those derivatives will need a chain rule when you get to it. But this function is first and foremost a chain rule question because you'll be dealing with this chain rule part first, and then the product will come when you're taking the derivative of what's inside. So the product rule is a secondary thing. So that helps to think of it that way before you start. Okay, quotients of functions. Again, this first one, this is just a polynomial over a polynomial. So you only will be using the quotient rule in this example. There's no chain rule needed. Here, however, yes, first you think about it as a quotient rule. Okay, you do the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. But when you do the derivative of the top, you will have to incorporate the chain rule because the derivative of the top has that where it's a function being raised to the power 3 instead of just a variable being raised to the power 3. Okay, another example of a quotient where you would need the chain rule is if you had, let's say, x squared plus 3 over x squared, and then that was all raised to the power 3. So similarly, this one would be a chain rule question first. You'd have 3 blah to the power 2, but then when you go to take the derivative of this blah, this inside function, you will need to use the quotient rule. Okay, and finally, in real world problems, let's say we have this example where we have the cost of an apartment in Leamington depends on the population, and then the population depends on the time. So you don't need the chain rule if I ask you what is the population, or when the population is 35,000, can you find the rate of change of the cost of an apartment with respect to the population? So you don't need it there because these all just involve cost at population, which doesn't go into the next level of information, which is time. So in this case, this is just asking for DCDP, which you're able to find, okay, since cost is already a function of population. But this one is asking for the change in cost with respect to time. So because cost is not a function of time, you would need to do DCDP times dP/dt. And that is your chain rule that gets you what you need. Okay, so I hope this short note helped you understand when you need the chain rule and when you don't. Thanks for watching. Hope you learned lots.